Hello, and welcome to our Project 1 demonstration for the Fall 22 Real-Time Embedded Systems course. I'm Daniel Neal in conjunction with my partner Brad Finnegan, and in this video we'll be demoing an Arduino application that translates user input ASCII strings into Morse code on an LED. The program shown will be a sketch written in Arduino IDE. It consists of a loop that polls in round-robin fashion from the serial input device into the Arduino Uno. When a user input string is received over the serial bus, the program parses the ASCII characters into Morse code equivalents and executes the Morse code over its I/O pin by asserting and deasserting high and low with appropriate Morse code timing. This round-robin loop runs indefinitely until a specific sentinel character is received from the input. Moving on to our hardware layout, which you'll see in action briefly. This fritzing sketch shows our general design. The Uno's GPIO pin 8 is connected to voltage high, supplying power for the diode. It connects to a 220 ohm resistor, and the voltage flows through the light-emitting diode, which is grounded back into the Arduino. Our serial connection between the Arduino and my PC is facilitated by this USB port, supplying both data and power to the overall Arduino. A schematic view shows much the same, with a little more specificity. Now for a quick look into the code itself. Our define statements lay out the GPIO pin we'll be assigning to output, number 8, as well as the relative timing for the Morse code components. We've implemented a DIT, or the single atomic unit of Morse code, as 300 milliseconds, and a DA, which is 3 times a DIT, will be 900. Our sentinel character for this demonstration, 60, corresponds actually to the less than sign, but in this setup it could be modified to be any ASCII character that is not relevant to the Morse code set. The sketch begins by setting up the Arduino, assigning our I/O pin to be an output, as well as setting up the onboard LED and turning it off. We establish our serial connection with a baud rate of 9600. And we set this I high, which as you see activates the while loop inside of our main loop in the code. And I'll go ahead and upload this to the Arduino real fast, as well as open up the serial monitor, so you can see that this next statement, printing over serial, shows up on COM3, which we've specified to be our serial port, but more on that later. Right now it's waiting to receive any input, and while it receives none, it does nothing. The Arduino is just stalling, or more accurately, polling the serial input. Once it has been signaled that it's received a string, it reads it in, trims off any new lines, and then outputs it back to the user, which you'll see in a moment. It modifies the string to lowercase, because our switch statement is case sensitive, then jumps into an interior while loop, iterating through all of the characters in the input string. Now if it finds a sentinel character, in this case the less than sign, it prints out to the COM3 serial port, sets I to 0, and breaks from the entire while loop, effectively shutting down this round-robin polling scheme. However, for any other character, it calls the parse letter function, sending in the character at the current index of the string. Then when it's done, it calls an additional wait function and moves us one character forward before resetting the loop. Further details are in our Morse code helper functions, the most obvious of which are our dash and dot functions. In Morse code, a dash is 1 DA long, which is 3 dits, and a dot is a single dit. And to execute each of these, we assert high onto pin 8, activating the diode for the specific delay time, before asserting low, turning the diode off. After each individual dash or dot is a single dit to satisfy the intra-character specification of Morse code. That dit, along with 2 more dits, a single DA, establishes the inter-character spacing of Morse code, which is 3 dits per individual characters. Now looking one level above, we have an intermediary helper function, which accepts a string of Morse code, that being a string exclusively of dashes and dots, and it translates these into the dash and dot function calls, allowing us to directly execute a Morse code string. This function is driven by the meat of our setup, the parse letter function, which consists of a large switch statement defining the string representations of every ASCII character translatable to Morse code. And this was made to be relatively human readable. For example, an A is a dot followed by a dash in Morse code, A G is a dash dash dot, the popular SOS, dash dash dash, and dot 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 make for an easy visual verification. We've gone beyond just alphabetical characters as well as numeric into some special characters as well, in accordance with the Morse code standards. The character most worth mentioning here is the blank space, because an inter-word delay in Morse code is 7 dits total, which for us is constructed in a bit of a makeshift fashion, using the trailing dit of the prior dot or dash, plus the 2-dit new letter call in our main loop, in addition to this 2-dit delay, followed by the 2-dit new letter call in the main loop prior to the next letter. All in all, the math works out, causing a delay of 2.1 seconds in this specific program, or 7 dits. Anyway, onto the actual demonstration. I'll move this over here so I can side-by-side things in the actual video. Here you see our physical hardware setup as shown in our fritzing diagram. Pin 8 connected to power, connected through the resistor into the diode, and grounded back to the Arduino. I'll start off with one everyone knows, a good old SOS with mixed capitalization to show that our lowercase actually does something. Enter. We got 3 dits, followed by 3 long old DAWs, and S is back for 3 dits. And the loop returns to the top to prompt the user once again for more input. Now, if we're making something a little fancy like a password that requires some special characters and you're sending it over Morse code for some reason, I'll show that we can get some special characters inside of there. Say period and colon. And since I have this up on screen, we should be able to follow along from home. There we go. And now dit, colon, da, dit. Look at that. One final one, let's say hello world, and I'll show where the extended break between words actually shows up. This clip is sped up 2 times, but you can see the 3 DAWs of the O followed by the 7-dit spacing right here. That took longer than I realized. But if I enter our Sentinel character, we'll see that it immediately stops the loop and I'll no longer be able to input anything. It's been received. It tells me that it received the Sentinel, and now, no matter what I do, neither the LED works nor the serial terminal responds. But in our setup, we do not have to restart the device or re-upload code to get this working again. We just need to close the serial connection and open a new one, and it brings us right back to doing our cool thing. In addition, we can break the loop whenever the Sentinel character is received, even if it's inside of a user string. Like say we were going back for SOS, but we inserted the Sentinel inside of it, and then enter. S-O, and we're cut off. We do not display the last character because the Sentinel was received and we immediately break the loop. And that's the long and short of this demonstration. Thank you for watching.